Hi, welcome to Astro Journey UK. In today's video, what I'm going to be doing is taking a 4-panel mosaic image that I shot in the previous video, and I'm going to be merging that together to create one image within PixInsight. So if you want to understand how to do this in 4 relatively simple steps, then keep watching. So, as I said in the introduction, there's 4 relatively simple steps that need to be followed here to obtain an image that is eventually going to end up like this. This video is purely going to be around the mosaic processing, and then there will be a follow-on video which will run through the remaining processing steps in order to be able to get this image. So we have those 4 steps. One is the first step is image preparation. So what we will need to do is take these images, which have all been stacked within PixInsight using the script under batch processing, weighted batch pre-processing. They've all been stacked, and I've got these 4 panels in front of us. So the first step is image preparation. What we need to do is just make sure that we've cropped all of these images, removing any of the stacking artifacts around the edges of the frames. You'll notice that these are all one-shot color camera images, and therefore they have that sort of green cast to them, very dramatic green cast. We need to do some background extraction and either dynamic background extraction or automatic. Those sorts of things. Then once we've done those operations, then we move into step 2, which is plate solving, because the third step, which is using a feature called Mosaic by coordinates, you need to have these images already plate solved in order to be able to create the mosaic image and place those panels into the right places that they appear in the night sky. Once you've got that step, there will be the final step, which is actually merging those 4 panels that have been created by Mosaic by coordinates using the gradient merge mosaic process. All of these steps are actually relatively straightforward, so creating a mosaic shouldn't be too painful. So this process of using gradient merge mosaic and mosaic by coordinates is there to actually replace the star alignment version of this process. So I did a video of that in the past with the California Nebula, and that whole process uses star alignment on the edges and the overlaps of the mosaic in order to be able to build that mosaic over matching panels. That works okay, but actually this process works a lot better, so it's certainly worth using this as a first port of call whenever you're doing any mosaic imaging. So let's get into the first step of image preparation. So let's go through the first step of cropping these images. So they should all be the same, all the same size as each other. And the idea is to just get rid of image artifacts and things like that. So go up to process, all processes, and dynamic crop. So I'm not going to be too aggressive on here. I think, just taking a few pixels off of the edge of the corner. If you're doing this with your own images, zoom in, make sure you can see where the stacking artifacts are. I don't think there's actually too many visible on this at the moment. It's quite difficult to see. Normally you'll see a lot more noise around the edges. So yeah, just make sure that you're just cropping a little bit off the edge of each of these frames so that you've got the largest amount of stacked data, so you're increasing that signal to noise ratio as much as possible. So just hit yes with that. So that's the first one done. So that's all of these images now cropped. We're just going to save these so that we don't have to go back and do that again. Just create a folder called cropped. call it M38 4. Save this one as well. I'll just fast forward past this process because it's not really very interesting. And then just to clear the file names up, I'm just going to literally open these all again. The only reason for doing that is I just get shorter file names and these windows, and then they're just a bit clearer. So the next thing to do is dynamic background extraction, just to make sure that we're clearing away all of this greenness and removing any sort of light pollution gradients that you might get in your images. I'm going to keep this fairly quick and easy. I'm just going to use automatic background extractor here, but with your images again, either use ABE, which does work quite well quite a lot of the time, or use dynamic background extraction and use your favorite approach with that kind of image. But I'm just going to set it to subtraction, discard background model, replace the target image, and then just apply that to every one of these images. So now that we've done that, just re-stretch these again, and then you can see that they're beginning to look a lot more like we were expecting them to look, in terms of no crazy green backgrounds and things. And yep, you can see the flaming star nebula and the tadpole nebula there, so things are looking better. Again, I think there's a little bit of gradient here, so yeah, that's just AB maybe not being the best approach for doing this. But yeah, you can take that time for your own images, definitely. So I'll just save these quickly as well. So just selecting the image, Command and S, or Control and S if you're on Windows. I'll just share quickly, so these steps are all within the PixInsight documentation themselves, under the Mosaic by Coordinates help for that particular help page in PixInsight. So you can see here, none of this is kind of rocket science, but I'm just sort of sharing you this process. To be fair, I didn't know that this actually had how to actually do it within the help documentation. The next step that we need to do, as in step 2, is actually running the plate solving. But also one of the steps that you would want to do for this for these images is actually color calibration. So you can do color calibration manually. You can either use this color calibration tool here, where you set the white reference and the background reference, or actually you can use what works very well for me is the photometric color calibration here. So we're going to use that, but you first need to plate solve in order to be able to use this tool. So what we're going to do is start with step 2, which is going into the script, down to image analysis and image solver. You can do this on the active window, or you can do it with all of the files, and actually what I'm going to do is I'm going to do it with all of those files. So we're in our video folder under cropped, we can select all of these image files and say that we're roughly in the region of M38. This doesn't need to be very specific, but yeah, this certainly works. So that gives you the coordinates, and then you want to put the date and time for the image as roughly around the 9th of January to around the 20th, so that's all fine. It's picking up the focal distance and the pixel size from the actual image data itself. These are all FITS files, and in FITS files you have the image information, the telescope information are typically recorded as well. If you're using digital SLR files and things like that, they might be in there, but yeah, you'll soon find out, and if not, you just have to get that information from your imaging sensor within the camera itself. You'll be able to look that up on the manufacturer's website, and you'll know the approximate focal distance of the telescope that you're using. The RedCat 51 is 250 millimeters, but this actually comes through at 247.922. So once you've done all of that, you just hit OK, and it goes away and plate solves all of these images using the online database of star information, which means that we don't have to do all this manually. So again, I'll just speed up the video whilst it does this, because it does take a little bit of time to complete. So that's now complete. If you actually go over to the folder where these images are open from, you'll notice that there'll be there'll be an image with the extension WCS for every one of the images that you ran through that image solver process, and these are all the ones with the plate solved images, and that's what we're going to be using from this point onwards. So we can close those now. So I did mention that I just want to run photometric color calibration on these images, so we do need to open these up again. So go into processes, all processes, and find photometric color calibration, and then we can just run this, everything as default. Just drag the triangle onto the image and it will go away, get that information again about the image itself, and run the photometric color calibration against that image to give you the right white balance and colour of the stars in the background, etc. So again, this is another thing that takes a while to do. We've got 4 panels to do, so I'll just speed things up again. The thing I remember to do is turn off generate graphs, because I don't really care about the data that's going to come back. So run that again. So now that that's done, we can just save all of these images again, and then that means that we won't have to come back to this part of the process again. So we're now on to step 3, which is Mosaic by coordinates. So this is a script feature under the Mosaic menu, and you go to Mosaic by coordinates. So the difference with this tool mentioned earlier on, what this tool is doing is, you've already got the plate solved images, so it knows where they would be in the virtual night sky, and so therefore what it's going to do is place each one of these panels in the 4x4 grid of virtual space, and it places each panel in the right place but in an isolated image by itself. So I'll show you what the output will look like in a minute, but we'll just select these WCS images that have been plate solved and they've been color calibrated. And the really nice thing with this tool as well is, actually, if you don't tick any of these things, it works it out for you in terms of the best projection algorithm. So what it's doing from a projection perspective is, you might get this with normal cameras as well. When you're taking a mosaic and the camera lens is moving, there's going to be a little bit of image distortion there. This tool works all of that out for you, so that's another benefit on top of the star alignment approach. When it's trying to work out what the coordinates of the centre of the mosaic and the resolution, etc. You don't need to fill any of this out, you just leave it as it is. The only difference, or the only thing that you need to do, is select the output images folder. So we're in our cropped folder. We can just create a folder called Mosaic. Click open on there, and then that's everything, and you just click OK, and it's going to go away and do all of that calculation and creating those mosaic panels all automatically for you. So I think what PixInsight here is doing is something similar to Photoshop, in the way that with Photoshop creating panorama images and mosaic images and things like that, it's doing a lot of the heavy lifting for you, so you don't have to sort of try and manipulate things to make things look how they should look. So all of the images have been processed successfully now, so that's all fantastic. If we jump over to Finder again, we can see in the Mosaic folder we've now got 4 images that are all registered. So let's just have a quick look at one of these images, just so you can understand what it's doing. Actually, let's open a couple. You can understand what it's doing and how they kind of interact with each other. So because they all need stretching still, so I'll stretch that image and stretch this one. So you can now see we've got two image panels that are both in the right space. There's a little bit of overlap in the middle there, but that's they're all in the right space in comparison to using plate solving to say that image in the bottom right hand corner is in that portion of the night sky, and then the one in the top right is in the right portion of the night sky relative to both of those panels. So we've got 4 images where each of the images are all in the corner, and what we need to do now is actually merge all of those images together. So we can close all of this down, we don't need any of these images open anymore. What we're going to do is move on to the 4th and final step, which is the gradient mosaic merge tool. So that's under processes, under gradient domain, and you'll see gradient merge mosaic, and we'll just open that. Another similar tool in terms of you have to add all of the files first, so we can go into our mosaic folder, select all of the images, hit open, and job done. So this tool, the help indicates, yep, this tool implements the combination of several registered images, i.e. plate solved, into one image using gradient domain type operations. And it does this to ensure a smooth transition of intensities where those images meet, so where there's overlap. There's also a slight benefit of this over the star alignment process in that you don't need as much overlap, and potentially you don't need any overlap at all, but I think it's always beneficial to have a little bit of overlap, certainly when it comes to stacking artifacts and things like that. So this is very good. They do actually say in the help as well that you can actually leave all of these settings as default, but I actually found that didn't work for my situation. And I don't think it works for everybody as well, and they do provide some useful hints in terms of changing various things. So I've found that using overlays definitely worked better for me. They do actually say as well, when you get certain situations whereby you see sort of visible seams within the images where they've been merged, that you can try increasing this shrink radius. So we'll be doing that. And also the feather radius as well. When you get sort of problems with stars where they look a bit pinched and just don't look very natural, then you need to change the feather radius as well. So the values that I'm going to be using here, that I've already pre-tested that definitely work for me, is 6 for the shrink radius, and 85 for the feather radius. And yeah, disclaimer alert, I stole these from Russell's astrophotography video. It's worth playing about with these, but this process does take quite some time. So what I would recommend is changing the values from an extreme perspective, and then sort of halving the differences between those values until you get something that you're satisfied with. If you just increase it by 1 each time, then you're going to be there for a long time. And then all we need to do now is actually just hit the global apply button, and that will kick off this process. It definitely takes a long time, so I'm definitely going to forward past this, and then we'll show you the image at the end, and that is this activity complete. So that's finished combining that mosaic to create one single image. So let's just stretch that image now. So this is the stretched image. Everything's looking pretty good. Hopefully I'm not sounding too surprised there. You can see you've got the panels there. They don't line up exactly, however where they actually merge, you can see all of that has merged very successfully. If we just zoom in a bit, we can see that there isn't a visible merge line, which is fantastic. No stars look a bit peculiar or pinched or anything like that. It's all looking pretty good. So I'm quite happy with that overall. I just need to then move into the next phase of post-processing this image, which will be in a follow-up video next week. So I'd just like to say thank you very much for watching. If you found this video useful, please hit that like button. It's great from my perspective to understand whether you're enjoying the content that I'm producing. And if you want to see more things like this, then definitely hit the subscribe button, hit the bell as well so that you get notified of future videos. I'd like to also say thank you very much to all of the subscribers that I've got over the past 1.5 years or so. Everybody's massively supportive. I'd like to thank everybody who comments in my videos. You know who you are. Thank you very much. It's great encouragement, and yeah, can't be happier for all of the support that you provide. So I'll leave it at that. I'll leave you with this image. Make sure you hit subscribe and the bell, because there will be a follow-up video next week on this, where I finish processing this particular image of the Auriga constellation. So I'll leave it at that. Thank you and clear skies.